Good afternoon, everyone. I'm Hyunsang Choi from Naver. Today, it's really honor to be here in Moscow and to present our research here. Today, the topic of our talk is security analysis on smart speakers. Before we talking about smart speaker, let me introduce my company, Naver, briefly. Naver is founded in 1999. The HQ is located in Seongnam. You may never heard of it. It's near Seoul. And the main product of Naver is searching portal, same as Yandex. And we also have a global mobile platform line. And there are a number of services and products such as a web browser, Whale, and deep learning-based translate application, Papago, etc. And we have several global offices in Asian countries and US. In this talk, I'm going to give you an introduction to smart speaker, and we're going to explore the attack vectors of smart speaker and some security analysis on commercial smart speaker will be given. And we will explain some guidelines to the security of smart speakers. As you already know, smart speaker is a voice command wireless speaker which offers interactive action to human with an integrated artificial intelligence ability. And this slide shows an example of smart speaker, Amazon Echo. Smart speaker ecosystem usually have three main components: the device, and cloud-based voice assistant platform, and skill set. The device has microphones and speaker operated with Linux or Android-based operating system. And the cloud-based voice assistant system, like Alexa, is actually in charge of recognizing user speech, understanding the user's intent, and returning spoken result. The skill set enables users interact with human using more intuitive way using voice functions such as streaming music, setting alarms, and giving real-time information such as weather or traffic. The population of smart speakers are growing day by day. Like some industry insiders predict the number of smart speakers will evolve rapidly in the next few years. Some big players, such as Facebook, Samsung, Alibaba, will join the smart speaker market. Also, Yandex. Naver has 3 smart speaker products: Clover Wave, Clover Friends, and Clover Mini. And we have a special edition of Clover Friend, which is a minion version. It actually says, speak like a minion. So it's kind of fun. Users generally use the smart speaker to check weather and to ask some general questions, and to stream music and set alarms, etc. But the device, smart speaker, is just a kind of messenger. The real brain behind the millions of smart speaker devices and voice assistant application is cloud-based voice assistant platform like Alexa or Elisa, yeah. Yeah, to make machine understand what human is saying, we need to transcribe the speech data to text. This process is referred to as ASR, automatic speech recognition, and NLU is needed to understand what the text data. And then a machine look up the relevant data and decide how to respond and generate some semantic representation or response. And then the machine can generate the natural language text. And eventually, by using the TTS, text-to-speech, it can generate the speech data. Yeah, these slides look familiar to you. Yeah, you already seen this slide. Anyway, this slide shows the sequence of speech recognition and natural language understanding and etc. The speech recognition task today is driven by machine learning and a statistical language model. Speech recognition has been around for decades, but now it's hit the mainstream because deep learning make the speech recognition accurate enough. From these slides, I'll give you some examples of attack vectors and some analysis on security of smart speakers. We categorize the attack vector of smart speaker into hardware-based, network-based, and software-based attack vectors. And the hardware attack vector, there must be an external port, internal port, or debug port. And the flash memory can be also a good possible attack vector and hardware of smart speaker. And the microphone is kind of unique attack vector of smart speaker. To perform the network-based attack to smart speaker, most attacks can be done by sniffing, done by eavesdropping the network traffic among smartphone application, I mean the dedicated smartphone application, and smart speaker, and servers. Smart speaker is also a Bluetooth speaker, wireless Bluetooth speaker. So Bluetooth can be another attack vector of smart speaker. And each component of smart speaker ecosystem has the application. So the applications such as client operating system and client apps such as speaker application, smart speaker application, and smartphone application can be targeted. And also, server-side applications such as the machine learning model or system or servers can be an option of the attack. We have tested 5 commercial smart speakers. 3 of them are Korean product, and the other are Amazon Echo and Google Home. As you already know, Google Home is the most widespread smart speaker at the moment. And Google Home is also a popular smart speaker. The first smart speaker in Korea is Nugu, and the second one is Gigajini. They are product of Korean telecommunication companies, which are SK Telecom and Korean Telecom. Naver launched smart speaker last year. This slide shows the specifications of smart speakers. I mean, hardware specification. As you can see here, all smart speakers have wireless and Bluetooth communication. To perform, when you try to attack on some hardware-based devices, the first thing you need to consider is hardware ports. If there is a port you can access, then things gonna be okay. And as you can see here in this table, all 5 smart speakers have external or internal ports, and all of them have hidden custom debug port. If you can succeed to access to the system through the hidden debug port, you can highly have a chance to the root shell or firmware, etc. This picture shows the debug path of Nugu. It is at the bottom of the smart speaker. And as you can see here, there is USB OTG. Wave has its own custom debug board. If you can use this debug board, you can connect the smart speaker to computer. Researchers of MWR Info Security Labs succeeded to get the root shell of Amazon Echo. They used the debug pad at the bottom of the Amazon Echo. And as you can see here, they used the external SD card by attaching the debug board, the debug pad. And they succeeded to get the root shell. You can check the details on the URL. And another hardware-based attack vector could be flash memory. If you can dump the flash memory, you can possibly get the firmware data. But unfortunately, recently, most smart speakers encrypt their data, so you need to decrypt it to analyze. To attack the microphone of smart speaker, I mean, there has been proposed an attack on microphone of smart speaker. The attack named Dolphin Attack is proposed by the Chinese researchers. The main idea behind this Dolphin Attack is that if you can send the voice command to smart speaker, but if you can change the frequency to ultrasonic frequency, then it's inaudible to human. And but the smart speaker can still listen the voice command. So Dolphin Attack can be done, is inaudible to human, but speaker can be activated and also launch, can perform some commands. However, this Dolphin Attack has a kind of limitation. The hacker must be close enough to launch this Dolphin Attack, like several feet away. Okay, from now on, the rest part of this presentation will be given by my colleague, Youngseok Park. Thank you.
Hi, I'm Youngseok, and I'm going to explain the other parts, network and software attack vector. And this slide shows a test environment to analyze network traffic among each part of the smart speaker ecosystem. And we captured packet as a man in the middle using this wireless access point. Like all the other IoT devices, smart speaker needs an initial setup. And the initial setup is for connecting a smart speaker to servers and authenticating its user. This figure describes the typical steps of the initial setup. First, the user puts SSID and password of AP to a dedicated smartphone application, and this application sends them to the speaker. And the speaker can be connected to the server using this AP. Next. During the setup, an attacker can capture this red box packet containing SSID and password of AP. If this packet is not encrypted, an attacker can obtain the password of AP. And this is the actual captured packet of between GigaGenie and its smartphone application. This application sends this encoded data to GigaGenie. And the data was encoded with base 64, and we were able to obtain the SSID and password in plain text after decoding it. This could be a good chance for attacker to infiltrate the victim's home network. And the initial setup of Nugu was not encoded, so we were able to see the payload of this packet, but the password was encrypted. In order to find out this encryption algorithm, we reverse engineered the smartphone application of Nugu. Then we found out the encryption algorithm was AES. However, the encryption key was hard-coded in shared preference XML file, so we could decrypt the password like this 1, 2, 3, 4, 5, 6, 7, 8. And Wave has different initial setup process from the other smart speakers. Wave makes use of Bluetooth communication for the initial setup. In order to capture this Bluetooth packet, we used Ubertooth. Since there was no encryption in BLE packets, we could see the payload of packets. However, the Wi-Fi password, PSK in this figure, was encrypted. Again, we reverse engineered the smartphone application of Wave and found out the password was encrypted with AES, and again the AES key was encrypted with elliptic curve Diffie-Hellman algorithm. We were not able to decrypt the password because the key is regenerated for each setup. In case of Google Home, the Wi-Fi password is encrypted with RSA asymmetric key. And Amazon Echo is the same, encrypting with asymmetric key, so we failed to decrypt the password. And let's move on to ASR and TTS. A smart speaker sends ASR request to a server, and the server returns TTS response to the speaker. We captured these ASR and TTS packets. And in case of Nugu, it did not apply encryption in their ASR packets. And the captured ASR packets have fragmented voice data of the user. And this voice data was encoded with SPIX format. Then we were able to restore users' voice commands by collecting the fragmented data and using SPIX to Wave tool. And Gigajini also has no encryption in ASR packets, and voice file is sent with PCM format. ASR and TTS of other 3 smart speakers apply SSL in their communication, so it is difficult to get the user's voice command. And a smart speaker has to maintain a connection with a server to respond to user at any time. As shown in this table, keyboard live packets of Nugu had not encrypted before patched. Unencrypted Nugu's packet, keyboard live packet, had those authentication information, that token value. And this sequence diagram shows ASR and TTS flow of Nugu. RDV, real-time data viewer server, is for connection, is for maintaining connection with Nugu using the aforementioned token. When Nugu sends voice data with a token to ASR server, RDV server returns JSON intent data to the speaker. Then the speaker sends TTS request with that intent data to TTS server and receives TTS response. However, if an attacker sends voice data to ASR server with token hijacked from keyboard live packet, the attacker can get JSON intent data containing user's information. And we were able to get the user's schedule data like this figure by sending a schedule asking voice command to the ASR server with stolen token. And this is the demo video requesting schedule with stolen token. The speaker reads the schedule of the user back when the attack is performed. Because this is Korean language, I added subtitles. Let's see the demo. Could you play this demo? Nobody.
На презентации видяшка, она вообще работала. Давайте проверим, что она работает. Can you just click next, maybe?
Yes, yes. Skip.
This is a video, right?
Oh, thank you. When the attacker
한개 일정이 있습니다. 오후 1시 30분 병원. 9월 19일 목요일 한개 일정이 있습니다. 오후 3시 30분 미팅.
the sound is a little bit low. When the attacker sends this runs this arbitrary script, the speaker reads the user schedule out. And next attack vector is firmware over the air. Recent IoT devices update their application and firmware by downloading files via internet. If these packets are not encrypted, the attacker can obtain the firmware and use it for more analysis. This figure is captured OTA packets of Nugu. There were plain text of HTTP request with URL of release information and APK files. With this URL, we were able to acquire firmware of Nugu. Google Home also does not encrypt OTA packets. We obtained archived firmware file containing system image of Google Home. Other three speakers use SSL encryption for their OTA packets. However, Amazon Echo's firmware is publicly available on their websites. And radio frequency communication such as Bluetooth and NFC, Zigbee, is another network attack vector of smart speakers. Last year, Bluetooth vulnerability, Bluebone, was discovered. Security researchers showed that they can get a remote shell of Amazon Echo by leveraging this Bluebone vulnerability. However, this vulnerability is patched now for all 5 smart speakers. Next, I'm going to talk about software attack vectors. Most smart speakers have Android-based operating system except Wave. However, Naver also changed the operating system to Android for the next products, Clover Friends and Clover Friends Mini. And we performed port scanning on the 5 smart speakers, and the result is shown in this table. They open different ports between initial setup and general operation, and it would be able to attack on these open ports. Client applications such as smart speaker application and smartphone application is also likely to be vulnerable points of a smart speaker ecosystem. If an attacker can obtain firmware of a smart speaker, it is possible to find vulnerability or exploit that vulnerability by fudging or static dynamic analysis on firmware. And smartphone application attack vector is the same with Android and iOS attack vectors. And a server-side application, such as NLU, is also possible to be exploited. An adversarial machine learning on speech recognition system named Cocaine Noodles presented at Eugenics Wood 2015. An attacker can produce sound which is interpreted as a voice command to automatic speech recognition, but not understandable for humans. For example, they made sound like cocaine noodles for humans, but OK Googles for automatic speech recognition system. The same researchers proposed advanced attack on speech recognition system that is named hidden voice commands. It presented at Eugenics Security 2016. As you can see in this diagram, they even make noise-like sounds for human, but the speech recognition system understands it as a voice command. As a result of our in-depth analysis on the smart speakers, we proposed several security guidelines in this table. To mitigate hardware-based attacks, vendors have to remove or disable unnecessary debug ports and use secure ADB in case of Android. And microphone enhancement to suppress ultrasound range or inaudible voice command cancellation is required to mitigate the Dolphin attack. For the network side, they are better off not using hard-coded key and use SSL encryption. Public key pinning gives more secure communication. As for the software, they have to encrypt firmware and add and verify signature of firmware on update and installation. For machine learning, it is hard to enhance machine learning itself, so generating audible feedbacks for important and critical commands or speaker recognition. Speaker recognition can be a solution for machine learning attacks. And this is conclusion of this talk. Smart speaker market is growing rapidly, and in this talk we enumerate attack vectors in smart speaker ecosystem and perform security analysis on 5 commercial smart speakers. And we explore vulnerability of smart speakers and provide security guideline of them. And this is the end of our talk.